So we are going to discuss the first problem of weekly contest 471. Sum of element with frequency divisible by k. We are given an array nums and there is an integer k, and we have to uh, return an integer denoting the sum of all elements in nums whose frequency is divisible by k, or 0 if there is no such elements. An element is included in the sum exactly as many times as it appears in the array if its total frequency is divisible by k. The frequency of an element x is the number of times it occurs in the array. So we have to give solution in a way that the number which is occurring many times, like 3 is occurring 4 times, so we have to count 3 4 times, that is 12, and 2 is occurring 2 times, that is 4, and thus the sum is 16. So we have to you have to count the frequency. We will directly store it in a map. Let me directly come into the solution. It's an easy problem. So I have declared a map, then I have iterated through the nums and updated the map and stored the frequency of the numbers in nums, and initially I stored the answer as 0, and then I have iterating through the map and checked if my value for the given number is divisible by k. That means the frequency is divisible by k. Then I am updating answer as sum of frequency into the element, and then directly returning the answer. Now coming to the second problem, longest balanced substring. So in this problem we are given a string s and a substring s. A substring of s is called balanced if all the distinct character in the substring appears the same number of times. That means taking this string, we can say that from 0th index to the 3rd index it is a balanced substring, because the balanced substring is given here, and that the number of times the distinct character is occurring is same. So here a is occurring 2 times and b is occurring 2 times, so it is a balanced substring. This is only we have to count. Let me explain the second problem, second example. In the second example, you can see that taking this substring, this z is occurring 1 time, so it is balanced. Here also z is occurring 2 times, so only one distinct character is there, that is z, and it is occurring 2 times, so it is also balanced. Now if a is taken from z to a, it becomes unbalanced because frequency of a is 1 and frequency of z is 2. Therefore till this the maximum length is 2. Again here also you can see the maximum is 2 here also, right? So till here we have done. Now you can see that from here, let me explain this properly. So till this substring, it is very dark. Till this we have answer as 2 because the longest substring is 2 with the distance character equal, and again here we'll get z equal to 2 times and a equal to 1 times, thus it has become unbalanced. Now again we can see here from z to ABC, this is the maximum length. Z A B C, this is of length 4, so it is 4. Here it is AB, therefore it is 2. Now we are given constraint that s is less than 10 raised to the power 3. Length of s is less than equal to 10 to the power 3. That means we can go up to O of n square. So it is very easy. So what I did was, I have iterated through this one time. You can see here. First of all, I have made the answer as 0. Then I have iterated through the string and created a map. This map will store my frequency of the character. You can see I have used 2 loops because n square is acceptable, and then I have checked all the substrings, right? So what I have done is, first of all, there is I will iterate firstly till n, and then from the ith index j equal to I till n, that means if the I is 1 here, then I have taken my j from j to n, from I to n. So I am updating the frequency each time for the jth character in the map you can see here, and each time I am checking that if my frequency of all the characters are same or not. If it is not same, that means it is unbalanced, and it is unbalanced, so we have to move forward to check if it is balanced or not. So if it is balanced, then I am updating the answer as answer comma j minus I plus 1. That is this is the length of the substring till which it is balanced. So I am checking each substring. This is O of n into n into there is an ordered map, and I am updating the frequency each time. This is O of 1, and maximum length of map can be 26. This is 26. That means it will go up to 10 raised to the power 7. That is acceptable. Now third problem I haven't solved. fourth problem I did after the contest. Now the fourth problem is little bit hard, but I'll make it easy for you. So let us explain. Let me explain you the problem first. So we are given an integer n. That means and an undirected tree rooted at node 0 with n nodes number from 0 to n minus 1. This is represented by a 2D array edges of length n minus 1 where edges of I is y. That means we are given a two edges in which there is a this is the edge which is undirected edge from u to ui to vi. We are also given an integer nums where nums of I tells the positive integer which is assigned to node I, and a ti value is defined for the number of ancestors of node I such that the product of nums of I into nums of ancestor is a perfect square. We have to return the sum of all ti values for all nodes I in the range 1 comma n minus 1. So what we have to do, we have to return the sum of all the ancestors from the current index. Current index will go from current node will go from 0 to n, and for each node we have to check that the value from the node multiplied by the value from its ancestor, is it a perfect square or not. If it is a perfect square, we have to add, and doing this for each node, checking the ancestors till the root, we have to give the final answer. So let me explain you the first example. N equal to 3, edges are given as this, and nums is 282. So it is like this: 0, 1, 2, and the values are assigned as 2, 8, and 2. So we have to check for each node. So coming to the 0th node, there is no ancestors, so there is no any answer is 0 till this. And first of all, we will come to ith first node value is 8, so 8 into 2, this is equal to 16, which is a perfect square. So in answer I have to update 1. Now there is no children, so we can't go. We'll go back, and again from 0 to 2 we will come, and the value at second node is 2 and value at 0 node is 2, so its multiplication will give us 4, which is a perfect square. So answer would be updated as 2. Okay, I think you got the answer. We have taken this example now. So output is 3, 8, 2 and 2. That means this is one node. we have to return the number of ancestors excluding I itself. So for the first node, it is given nums of 1 into nums of 0 is 8 into 2, this is 16. 16 is taken, so answer is 1. Now for the 1 and 0, 1 and 0, oh sorry, this is not a tree, sorry, very much sorry. This is the first example, 0, 1 and 2. Its value is given as 2 and 1 value is given as 8 and its value is given as 2. In this tree, answer will come true, 2 only. Okay, and in this tree, let us see. First of all, the answer is 0. Now for the 0th node, there is no ancestor, so the answer will remain 0. Then we will come to first node. Then the first node, the value is 8 and its ancestor value is 2. So the multiplication of 8 into 2 will give 16, which is a perfect square. So the answer will be updated to 1. Now there is no ancestor of 1. Now coming to 2, ancestors are 1 and 0. Value of 2 is 2 and 1 is 8. Their multiplication will give 16, which is a perfect square. So the answer will be updated to 2. And from 2 to 0, 0 is also ancestor of 2. It is multiplied, it will give 4. So the answer will be updated as 3 because 4 is a perfect square. So I think you have got the examples properly. One more example I want to take. This one. 0, 1, 0, 2, 1, 3, and the values are 1, 2, 9, and 4. So coming to the 0th, first of all the answer is 0. Coming to the first node, 0th node, there is no ancestor, so answer will remain 0. Coming to 2, its value is given to us as 2. Coming to the first node, its value is it is the first node. Its value is 2 into 1, which is not a perfect square, so it will not update. Then we will go to 3, and in 3 it is 4, value is 4 and the ancestor are 1 and 0. So 4 into 2, it is not perfect square. For 3 and 0, it is a perfect square because 4 into 1 equal to 1. It's a perfect square, so the answer will be updated to 1. Now in the second node, the value is 9 and its ancestor is 0. So 9 into 1, which is a perfect square, and answer will be updated to 2. Yeah, the answer is 2. Now the constraint are n is less than equal to 10 raised to the power 5 and the edges length are from 0 to n minus 1. Input are generated so that the edges represent a valid tree. So for this problem, with what approach I have used is so I will share you my intuition first. We have n less than 10 raised to the power 5, right? And edges are given and also there is a nums which will give me the numerical values for the particular node. So I have done so first of all, from the given edges I have created a adjacency matrix. Then for each nums value is 282, right? For each nums value, how can we tell that the product of two numbers is a square number, is a perfect square? So this is the approach. Let n1 is something and n2 is something, and it will give us a perfect square n, right? So it should be n should be a perfect square, so it should be under square root, right? And here will be n1 and it will be n2. So if the n1 has something like this, x power x1 power 2, x1 power x2 power 3, x3 power 6, and n2 as y1 power 2, y2 power 1 and y3 power 3. So if it is a even means 6 is even, so out of the root it will go, right? x3 will go out, and here y1 is even, y1 will go out. If we put n1 and n2, the given values are this. If you put, the square terms will go out, right? And there is also x1 will go out, and the remaining are x2 power 3 and y3 power 3. That means we have x2 is power 3, that means till the even power, that is x2 power 2 will go out of square root, and it will become x2 here, and one x2 will be remaining. This will be under the square root, and here y2 will also be on the square root. So the product of y1 and x2 should be a perfect square, right? That means x2 should be equal to y2, right? x2 should be equal to y2. So what we got is, for a given number n1, we can tell will it make with perfect square with n2 or not, as we will prime factorize n1. Prime factors will come like this, and we will prime factor n2. It will be like this, and all the odd powers, that means we have something x power 1, x2 power 2 and x3 power 3, and here y1 power 1, y2 power 4 and y3 power 3. So all the even powers will go out of the square root, so they will always be a perfect square. Now for the odd ones we have to check. That means the x3 into y3 into y1 should be a perfect square. Okay, that means if it is a perfect square, that means the x3 should be equal to my y1 into y3. Is it clear? Y1 can be 1, let me take 1, and y3 as 3, then x3 should be 3, and this will be equal to this, and then it will be a perfect square. Okay, because if they are equal, x y1 is 1, there is no problem with 1. If they are equal, that means it will be 3 power 1, and here it will be also 3 power 1. In the n1 side is 3 power 1, and in the n2 side is 3 power 1, and on multiplying this we will get the even power as 3 power 2, and its square root will always be a perfect square. So I think it is clear to you. So coming to the second step, I have created a hash map which is storing all the let me call this as kernel value of all the numbers, what I have named it here odd factor. Okay, odd factor storing the odd powers or power 1, storing the power 1 of all odd times prime factors. Let me show you how I am storing this. First of all, I have created the adjacency matrix, and then for the odd factor I am iterating through the last index of nums, and I am storing in num as nums of j, and then checking if there is already a value existing in the map. And firstly I have taken as product 1, and then I have done this. This will give me a prime factors, and checking if the factor is odd, then I am updating this prod is updated by this divisor 2, divisor I. So after updating prod, and at last we are checking if the num remaining is greater than 1, so then we are again multiplying. The odd factor will now come as nums also equal to third, right? So my map have stored all these values. Then I have done DFS, from the root, which is 0, taking the first parent as -1, and this only I have done DFS. And in this DFS what I am doing is let me show you one tree. So starting from the first node, the DFS will go to this node, and it will check the ancestors, if there is a common value or not from the odd factor hash map we have created. And then after iterating this subtree, it will go to this, and then again it will go here. First of all, here it will check with the ancestor. For checking this, we have created a array hash. Hash is storing this is a recursion. This is the first. This is the second recursion tree, we can say. In this recursion tree, it will go first of all here, then here, then here, and then here, then here, then it will go above, right? So each time it is going to its children, we are updating hash. How we are updating hash? Hash will be the value of this odd factor we have created, right? Odd factor is giving me some integer value. So the odd factor is stored in a number, let us say OD. OD is equal to odd factor of the given node. This will give me the value, and in this till here, odd factor is storing some of its ancestor. If it is here 3, if it is in 3, so it will update each time the frequency of the node in which it is coming, right? After it is updated, we again perform the DFS on its children 4 and 5. After doing the DFS, it will again go to this. Then again we have increased our hash value and updated the frequency. And then whenever it will backtrack, we have to reduce the frequency, because what if the values, let me say the odd factor value is here is 2, here is also 2, and if it is added again, then it will create problem. So we are decreasing the frequency whenever whenever we are backtracking. Okay, so we have decreased the frequency, then again it is increased here, and whenever it is increased, we have created a answer value which is initialized as 0. Whenever it is updated, we are always adding, like in the 6th node we are here. Okay, so whenever we are here, the previous ancestors values frequency are updated in hash map here, and if we are here, its value is also calculated before increasing its value's frequency, we are adding to the answer the this value each time. Like here it will be 3, and here 3's count is 1. So for this 6 we have one ancestor whose value is 3, so we are updating the answer as 1 here, because there is one which is frequency, right? Let me show you with the code. So we have performed DFS. DFS is first of all we have initialized a hash map and answer as 0 in the DFS, and there is a node, and odd num is the value of the, it is the that odd factor value, and each time we are coming to a node we are updating answer as answer plus hash of odd num, which is, this is the odd term, this is the frequency of the current value of its ancestor. And then after that, for that index we are updating, then we are again performing DFS with the check that my current node is not equal to a parent. Then I perform DFS, and then after doing this we have decreased the frequency, so the total answer will be in answer, so we are returned answer here. So thank you. I hope you liked. Tell me what can I do more. Like I want to bring some post contest discussion of code forces also. Comment if you want. And please give me suggestions how can I improve this video quality and teaching style.